welcome to TaiyangNews, and we are at Intersolar Europe, the world largest solar show in Europe today. And I'm at the booth of Solargis, where I'm with the CEO of Solargis, Marcel Suri, and he's going to talk to us more about what new do they have at Intersolar. Welcome to TaiyangNews, Marcel. So can you please tell us a little bit about the company itself? How long have you been around, and what's new at Intersolar for you?
Yeah, thank you. So the company is already 15 years on the market. We are well known as providers of solar and meteorological data for industry, for project development, but also for performance evaluation and forecasting. Our traditional role as data provider today is complemented by offering more software services which are used for energy design, for energy yield calculation, long-term prediction of the energy output, so that the projects are better prepared for the challenge of yet more and more increasing complexity of energy designs. We talk about new technologies such as bifacial PV modules, smart trackers, these power plants being designed in relatively complex terrains. So the software which we are introducing helps to deal not only with that, but also with the problem of projects being exposed more to weather variability, changing weather trends, and extremes. So the high resolution data and more physical based software is designed to show developers the potential risks of projects underperforming or even being exposed to damage due to changing weather.
And so nowadays we are talking about AI and machine learning, and so how does this help you in your software development, and how does it help your ultimate your customers?
Yeah, I think that's in question which comes quite often. I am getting two typical questions like, what about climate change? Because we are weather data providers, and what about AI? I always say that we still have to stick a lot with the basic physics. So whether we talk about weather, there is a lot of physics which is driving weather, and also a lot of physics which is embedded in energy simulation and conversion of weather data into electricity data. But of course there is a lot of uncertainty which can be resolved by putting AI or machine learning on top of physics. So we always have philosophy that everything which can be explained by physical equations should stay like that, but where the uncertainty comes, this is where the more advanced statistics and AI can help. So we take it seriously, but it also takes some time to come up with solutions which can reliably operate at a global scale. So while training a model for certain geography, let's say India, may work well for India, but if the training does not include data from other climate zones, we may not trust the model at the global scale. So that's why the training of models and making sure that we can rely on their performance everywhere is a task which may take some time.
So how optimally can this performance data and this forecasting tools can work? Like, what more support do you require to make it work absolutely?
We aim to offer solutions, computational solutions, which are as accurate as possible, as close to reality. But let's not forget that we are combining the technology which is well understood in the laboratory condition, and we are putting it in a real geographical conditions which create a lot of uncertainty. And our objective is to employ models and data in a way that we can trust the results in every location, whether it is like a desert of Saudi Arabia or forests of Brasilia, so like Amazonia forest. So geography plays important role, but also interaction of weather with the technology, which is location by location different. But you are right, the approach needs to be developed so that the developers and operators of projects can rely on the data and software services in the same or similar way everywhere. And that's constant challenge.
So also when we talk about forecasting, a lot also depends on the module technology, the cell technology, which keeps changing even as we speak. It's constantly evolving, and over the past few years, it has evolved really rapidly. Different technologies have come in. So how does that impact your work?
I think that's an interesting question. I like that you are coming with this. The problem of software solutions which have been in use for quite some time is that there is a lot of empirical, a lot of simplified models and empirical description of complex phenomena. Today, with high-performance computing, with much better physical models, we are able to describe basics which help to also address the performance of the more complex technologies. Whether we talk about the new PV module technologies or inverter, the way how inverters operate, or trackers. Trackers become more and smarter, and with more physical models, they are able to deal with this phenomena in a much more controlled way. On the other hand, we need also to be sure that the data which is available is supporting those complex models. And here comes also a topic that it's, on one hand, we are developing more complex and more robust models, but we also must be sure that the data which is used in these models are of the quality which is expected and which can be assured. So I would say there is a lot of innovation which is supported by cloud computing, by new modern 3D design technology, 3D data visualization technology, design visualization. And this makes it possible to provide more insights into the designs, to inform technical staff, but also financial staff about the way how for example, hybrid system, PV plus storage, will operate on a technical level, but also at the level of business model which the financial people have in mind. So I would say we live in a transition from relatively simple, relatively simplified and low-level numerical modeling to much more high-performance modeling, giving completely new insights for the industry, how to develop and operate not just one single project but entire portfolio, so that we avoid, or so that we have a PV which better interacts with energy grid, so that we have PV which is not only seen as power generating technology but also grid supporting, grid forming technology. And these new numerical models, better data, better visualization tool help us to get there, and so that we as PV industry are seen as right partners for the grid operators to help them in managing grids which are in in conditions of being having a lot of capacity which comes from variable sources. So that's our vision for for future.
So back to Intersolar. So what is it that you have brought to Intersolar today?
I would say just like we have launched a new software, Solargis Evaluate, which is a part of our suite platform services, where we are trying to address those things which I mentioned, like having the software which is offering highly granular data, addressing the more like the weather variability and weather risk issues with new 3D designing tool which can help better to understand how environment affects the various PV components. So the software which we believe will offer a range of new insights on how to design and operate solar power plants with a better comfort under more and more competitive environment. Something like that.
All right. Thank you so much and enjoy your Intersolar.
Thank you very much.